chapter that is completely devoted to right triangles. Okay, every single problem has a right triangle on it. So there's a lot of different things we can do with right triangles, and everything you learn in this chapter, you're going to use on pretty much any standardized test you will ever take. So the ACT, you're going to see this. Any AccuPlacer you would take to get into college to see what math classes they would put you in, you will see all of this. The Pythagorean Theorem you've probably seen before. That's what we're going to talk about in this first section. And actually, we're lumping together two sections, 7.1 and 7.2, because they are so similar. But let's quickly review. If we have a right triangle, there's always two legs. Those are the ones right by the right angle. And the hypotenuse is always straight across from the right angle. And it's always the what? What's the longest? Hypotenuse is always the longest side. Okay? So the Pythagorean theorem in sentence form is right here. The sum of the squares of the legs are equal to the square of the hypotenuse. Okay, so looking at this, this is the most important part of setting up the Pythagorean theorem, that your hypotenuse always goes in for c squared. A and B can be either leg. It doesn't matter what order you put those in. But as long as you got your hypotenuse in for c squared, you're good to go. We already talked about that up above. It's always the longest. So let's try a few of these problems. All right, first one. Okay, I typically, if I'm going to help you on one of these problems, I'm going to ask you to do the c squared first, because that's the most important piece to make sure it goes in the right spot. So what is our c squared going to be on this picture? It's the x. Okay, that's the hypotenuse right there. So x is on this side. And then the 100 and the 75 do not matter what order you put them in. Okay, so you got those. Somebody help me out with 75 squared. Okay, so now we have these two numbers over here, so we should combine like terms, put those together. And now what's the last step? So right now we have x squared and we want just x. Yeah, let's square root both sides. What is that? Okay, so we figured out that the hypotenuse is 125. Let's try this one. Which one is c squared on this one? Yes, this is your c. So we've got 5 squared, x squared, and 13 squared. This one we could probably do without calculators. So we've got 25, 169. What would we do here? We're trying to solve for x, so we're going to want to move this. This is 144. So if we square root both sides, what do we get? We get 12. Okay, now both of these situations we got integer answers. Okay, we didn't get a decimal. Sometimes you'll get a decimal and that's okay. But when you don't get any decimal answers, these are what are called Pythagorean triples. Okay, so if you want to memorize these, you can. So if you see a 3, 4 triangle, you know the hypotenuse is always going to be 5. But the Pythagorean theorem also works. So if you don't want to take the time to memorize these, you can always just rely on using a squared plus b squared equals c squared, and you'll always get the right answer that way. The first triangle was just one of these multiplied by a number. Which one was it? It was the 3, 4, 5. What did we multiply the three numbers right here by? We just multiplied 3 times 25, 4 times 25, 5 times 25. So any multiple of these would work up here as well. So just know that if you get all whole number answers, integers, they're just called triples, Pythagorean triples. Some kids like to memorize these as a shortcut. Others don't. Okay. Now we're going to look at the reverse of this. Okay, because the Pythagorean theorem only works on what kind of triangles? Right triangles. Okay, but we are able to use the Pythagorean theorem to tell us if we have a right triangle or not, or if we have an obtuse or acute triangle. So if we end up getting two equal things, if that equals that, then we have a right triangle. If c squared is bigger than a squared and b squared together, then it's an obtuse triangle. If c squared ends up being smaller than those two put together, then it's an acute triangle. So we're going to try that with these three examples. So we are going to write it a little bit backwards here. So c squared is going to be on the left. Essentially, we're doing this. We're trying to see if they're equal to each other. We got a squared plus b squared. What has to go in for c squared? I heard two different answers. Why does it have to be 9? The longest side. C squared is your hypotenuse, which is the longest side. So we do need to put 9 squared over here. And then the other two in for a and b. So we're just going to see what happens. What is 9 squared? What is this put together? Okay, you're not going to put an equal sign here, are you? Are these two numbers equal? Okay, if you put 81 equals 113 on the test, I'm going to mark it wrong because that's not true. You don't want to do that. What symbol should be in between here? Less than. Okay, now again, the focus with Pythagorean theorem is on c squared. So you're asking yourself, is c squared big, small, or equal? What is it here? C squared is small. So what kind of triangle would we have? Acute. Small and acute go together. Big and obtuse go together. So this is an acute, oops, spell it right, triangle. This right here is your answer. I'm looking for these two numbers to be the right two numbers in the equation, the right symbol here, and then what kind of triangle you have. Okay, so let's try here. What would be on the left for c squared? Yes, make sure you pick the biggest one. 16 squared and 30 squared. Somebody help me out. Yeah. What's this one? 256 and 900. So we got 1156. What about these put together? Okay, so this one is equal, so it's a right triangle. That's the complete answer. Okay, what goes in for c squared over here? 15 squared, 6 squared, and 11 squared. So we got 225, 36, and 121. What's this over here? So we need to put a greater than symbol there. What kind of triangle? Again, the focus is what is c squared? Is it big, is it small, or is it equal? Do you guys have another slide? Okay. Ready? Okay. So this is what your problems might look like. Instead of giving you just a list of three numbers, they give you a picture. Okay, this one has a root in it. Okay, the reason I'm going through this is because there are some of these on the homework. and also on the test, so I want to show you how to put it in your calculator. So if you could have your calculators out, that would be ideal. All right. We're trying to figure out what kind of triangle it is. So what is going to go in for c squared? Well, right now we don't know which one's the longest side. So let's first figure out what 3 times the square root of 5 is in your calculator. What is it as a decimal? 6.7? Okay, so which one's the longest? That one? Okay, so on this side, we need to have 3 times the square root of 5, the whole thing squared. I'll show you how to do that in a second. And then we got the other two sides. Okay, so first step is to figure out which one is truly the longest, because we can't tell just by looking at 3 root 5. We have to turn it into a decimal. So we figured out that's the longest. We put this over here for c squared. Now, when you put this in your calculator, it's going to automatically give you this parenthesis over here. So you need to close it, and then you still have the ones on the far outside, because you have to square the whole thing. So be careful with the parentheses. Make sure you have enough on there. Okay, if you do this correctly, you should get 45. Be able to get 45. Make sure you have a parenthesis to start, and then a 3, then square root, close your parenthesis, squared. Okay, essentially this is what you're doing. I'm going to move this down. You are squaring everything inside the parentheses. So you're going 3 squared, and you're doing the square root of 5 squared. Well, what's 3 squared? 9. What happens to squaring and square rooting? Yeah, those are the opposite of each other, so they cancel out. So we've got a 5 there. What's that? Well, that's 45. That's where the calculator's getting 45. Okay, well, over here, let's finish the problem. We've got 4 and 36. So what's on the right here? Okay, so we've got to have this symbol along with what word? Questions.